Welcome to my channel, dear students. This is a very important video today, and this is the golden ratio. It's called the golden ratio, whose value is root 5 plus 1 by 2, and that is equal to 13 by 8 plus 1 over 32 root pi, and summation from 0 to infinity, and minus 1 whole to the power n plus 1 and 2 to the power minus 2n, and gamma 3 plus n plus 3 by 2 and over n plus 3. And this problem given me Paul to my messenger. See, here is the solution. Very interesting problem for you, Paul. Here is the solution for you and all the viewers. For start this solution from right hand side, and first we write the value of golden ratio. And that is equal to root 5 plus 1 by 4. 2 plus root 5 plus 1 by 2 here. Now we write here right hand side, and that is equal to 13 over 8 plus 1 over 32 root pi, and that is summation from and 0 to infinity, and that is here minus 1 whole to the power n into 2 to the power minus 2n, and that is gamma n plus and 3 by 2 and gamma n plus 3. So for the simplification of this expression, and 13 by 8, and this is 1 over 32 root pi, and this is from n equal to 0 to infinity, and that is minus 1 to the power n, and over this is to the power plus 2n, and for this gamma n plus 1, it can be written as n into gamma n, like that. So it is, let us assume n plus half plus 1, so that's why n plus half, this is here n plus half, and gamma n plus half, and over gamma n plus 3 here. Now need to find the value of this is the very important point, and that is equal to this is here root pi, and this is the multiple of and 2n, and that is equal to 2 to the power 2n minus 1 into okay, therefore the value of this is here n plus half, and that is equal to root pi, and this is gamma 2n over 2 to the power 2n minus 1 and gamma n. Now put the value of this here, see, and this is equal to 13 by 8 plus 1 over 32 root pi, and that is summation n equal to 0 to infinity, that is minus 1 whole to the power n plus 1. So this is here n plus 1, minus 1 whole to the power n plus 1, and for n plus 2 here, if we take LCM, this is and 2 to the power 2n plus 1, this is 2n plus 1, and this is 2n plus 1 here. So, and this is 2 to the power 2n plus 1. If we take LCM 2, then power be added here, 2 to the power 2n plus 1, and now gamma n plus half, and that is here root pi gamma 2n over this is 2 to the power 2n minus 1 and gamma n. Okay, and this is equal to 13 by 8 plus this root pi and root pi are cancelled out, and this is from 1 by 32, and summation n equal to 0 to infinity, that is minus 1 whole to the power n plus 1, and this is here 2n plus 1 and gamma 2n gamma 2n. Okay, this is gamma 2n, and over this is 2 to the power 2n 4n, and this is 4n, and this is gamma n, and gamma n, okay, and gamma n plus 3, sorry, this is n plus 3, I'm missing, this is gamma n plus 3. Now I need to prove this problem by the method of beta gamma functions. This is here, we know this is 2 times of integral 0 to pi by 2 and sine to the power mx and cos x to the power n dx, and that is equal to beta function of m plus 1 over 2 and n plus 1 over 2. Okay, and also beta x comma y, and this is equal to beta function of that, this is gamma x and gamma y and over x plus y. See, if we compare with that, so we can write here m plus 1 over 2 is equal to x, and that is equal to m equal to twice x minus 1. Similarly, if we compare with y equal to this, then n is equal to twice y minus 1. So therefore, from 1, and this is here 2. So from 1 we can write, and this is okay, this is m. Actually, this is x and this is y. Okay, this is x and this is y, and that is equal to gamma x and gamma y over gamma x plus y, and this is equal to, if we put in place of m, this is twice times of 0 to pi by 2 and sine x, and this is here sine x to the power, if we if we let us assume here x, so this is theta and this is theta, put here theta, so this is theta to the power, this is theta to the power, in place of m, this would be twice x minus 1 and cos theta to the power twice minus 1, and so this is d theta. Okay, this is here d theta. Now replace here is x, so therefore beta function of x comma x, and that would be here gamma x and gamma and 2x, and this is equal to 0 to pi by 2. This is sine theta to the power 2x minus 1. This is 2x minus 1, same as cos theta to the power twice x minus 1, and this is dx. Okay, this is d theta, so this is d theta. So this is equal to 0 to pi by 2. Both the power are same here, so sine theta and cos theta, and to the power 2x minus 1. So multiply by 2 here, so the degree of this here 2 to the power 2x minus 1. So for balancing, we multiply here 2 to the power 2x minus 1, and this is equal to 1 over 2 to the power 2x, okay, minus 1. So this is 0 to pi by 2 and sine 2 theta and to the power twice x minus 1 d theta. Let and 2 theta is equal to pi. And this is their notation, which is known as golden ratio. So we didn't use the phi. So this is d alpha, this is twice d theta. So this is equal to 1 over 2 to the power twice x minus 1, and this is from, if we put 0, if we put 0 0, then if we put pi by 2, then we got here pi. So this is pi, and this is here sine 2 theta. 2 theta means here we can put here alpha, and in place of d theta, and that would be our half into and d alpha. Okay, okay. Okay, this is 2 times of that. 2 are missing here, so this is 2 times of that, 2 times of that, so 2 are cancelled. So 1 over 2 to the power 2x minus 1, and this is 0 to and pi by 2, and this is 2x minus 1. Okay, and this is 2x minus 1, this is alpha, to the power 2x minus 1 and d alpha, and this is 1 over 2 to the power 2x minus 1 0 to pi by 2. Okay, no, this is pi by 2, so pi by 2 2 pi. Okay, this is sine alpha and whole to the power 2x minus 1 and d alpha. For this, let us assume so phi, okay, no, psi, and this is equal to alpha minus pi by 2. So d psi is equal to, and d alpha, so this is 2 to the power twice x minus 1 0 to pi by 2, and this is sine alpha and twice x to the power minus 1 and d alpha, plus 1 over 2 to the power twice x minus 1, and this is 0 to pi by 2. If we put pi by 2 here, then you got 0. If we put pi, then we got pi by 2. Okay, so 0 to pi by 2, and again if we put here alpha, and that is pi by 2 plus psi, so it would be here cos psi whole to the power twice x minus 1 and d psi, and both are same. If we apply the property that is 0 to a and f of a minus s and dx, and this is equal to, okay, apply the property 0 to a f of x and dx, we can write here 0 to a f of a minus x and dx. So from that we can say easily this is both are same. So this is 2 over 2 to the power twice x minus 1, this is 0 to pi by 2, okay, and sine alpha and to the power twice x minus 1 and dx. Sorry, this is, if we put the value at theta, represent in place of alpha, you can write here theta. And again from this relation here, you can write from this equation, if we mention that this is as a 1 and this is as a 2, so this is as a 3. So from 3 now, so from 3 we can write here, if we replace this is x and this is half, so we got here x and this is half, so here is x plus half, okay, which is our query. So that's why in place of x we put here half, so this is an x plus half, and this is x and this is half. So this is 2 times of, and this is 2 times of 0 to and pi by 2. See, if we put both the same, if we 2x in place of y, this is as a y, right, in place of y you put here half half half, so this is sine x sine theta and to the power twice x minus 1 and cos theta to the power, actually if we put here half, for the, this is 2 times of half minus 1, this is 0, so this is 0 and d theta. So therefore this is as a same as from the figure of this is, okay, this is 2 times of 0 to pi by 2 and sine theta and whole to the power twice x minus 1 d theta. So both the same. So from this we can okay, from this equal to this actually, so gamma x and gamma x over gamma twice x, and this is equal to 1 by, sorry, this is here 2 to the power, okay, okay, 1 over and 2 to the power, this is equal to, from this to this is equal to 2 to the power 2x minus 1 and 2 times of that, this is 2 times of that, we can write here gamma x gamma half over gamma x plus half. So from this 2 factor are cancelled out, so from this we can easily, and this is as a pi, Okay, and this is multiplied by this gamma x plus half, and this is okay, this is into 2 to the power and 2x minus 1 is equal to, and this is root pi into factorial gamma twice x. See, root pi into gamma twice x and 2 to the power 2x minus 1. Okay, same as now replace in place of x we put here, and then we got the relation this, and from that we can easily find this value. Okay, so this is question number 3, 4, and this is 4. Okay, so from this relation we can find easily and put gamma n plus 1 is this. Okay, from this relation. Okay, now simplify this expression. After that, see what happened here. Now multiply here 2n factorial, only 2n, and this is equal to okay, minus 13 by 8 plus 1 by 32, and this is summation n equal to 0 to infinity, and this is minus 1 whole to the power n plus 1, and this is 2n plus 1 into 2n and gamma 2n. Okay, this is 2 to the power 4n gamma n plus 3, and this is into 2n. So see, 13 by 8 plus 1 over 32 and summation n equal to 0 to infinity. So this is gamma 2n plus 1 minus 1 whole to the power n plus 1, gamma 2n plus 1, 2n into gamma 2n. So 2n into gamma 2n is gamma 2n plus 1. Again 2n plus 1 into gamma 2n plus 1, this is gamma 2n plus 2 over, and this is 2 to the power 4n, and this is 2, this is 4n plus 1. If we n into gamma n means n plus 1, gamma n plus 1, this is n plus 3. Okay, so from this relation again we can rewrite here 13 by 8, and this is here 13 by 8. Okay, and summation n equal to 0 to infinity, and this is minus 1 this is summation n equal to 0 to infinity. Okay, and 32, this is 2 to the power 5, 2 to the power 5, so minus 1 whole to the power n, and factorial 2n plus 1, and 2 to the power 4n plus 6, factorial n and factorial n plus 2. Again rewrite 13 by 8 plus summation n equal to 0 to infinity, that is minus 1 whole to the power n, factorial 2n plus 1, and this is here okay, so this is and 5. Okay, this is here 5. So here is the goal. So now this expression and 5 is equal to the golden ratio, and that is equal to root 5 plus 1 by 2, so 1 over 2 and root 5 by 2, so it can be written as this is root over 5 by 4, this is half plus 1 plus 1 by 4 whole to the power actually half. So this is the main factor of this expression from the binomial expansion, and this is if we know the value of f of 1 plus x whole to the power n, we can write here 1 plus nx, so n into n minus 1 by factorial 2 into x square, like that, and the rth term, and that is here n minus 1 n minus 2, this is the general term, dot dot dot, For the general term, this is n minus r plus 1 over factorial uh, r, as this is r, and x to the power r. So plus order to infinity. See, look here, in place of x, this is here 1 by 4. So this is the main factor. So therefore, so phi is equal to 1 by half plus 1 plus 1 over 4 whole to the power 2. It can be written as like 1 plus n into x, this is 1 over 4, n into n minus 1 by factorial 2 into x square. So half minus 1, half minus 2 dot dot half minus n plus 1 by factorial n I put as a r. So, and this is x to the power r plus dot dot to infinity. Now simplify this expression. This is equal to, if we add this two term, okay, I am wrongly written here. Here is a more half plus this. So if we add this 3, this is 3 by 2, and this is 13 by 8, and this is a 13 by 8 plus summation. So need to express as a summation from this to this. So see, first this is here factorial r, and see number of, see here in this expression each and every factor carry 2. So the number of 2 here, so therefore the factor of here is r. See, if we get here factor 2, factor n and n minus 1, then we got here factorial 2. See here factorial r. So number of 2 here r times of that. So this is here 2 to the power r. Okay, and here is minus 1 whole to the power. See, this is your factorial r. Number of factor here is r, but from the second term we got here minus sign. So number of minus 1 is r minus 1 times of that. So their product is r minus 1. If we take LCM, we got here 1. Minus have taken common. This is 1. Then we got 3. Then we got 5. After that we got here 2 minus 2r plus 3, as minus common taken common. So the other factor is here, and then the factor is here 2r minus 3 here. Okay, very interesting point here. And this is here, okay, actually this is here 4, 1 by 4, wrongly written. This is here 1 by 4 to the power r. Actually I want to get this form. So this is here 5, and this is here 5, and this is here, okay, this is here 5. No, need to expression is this. Okay, so therefore 13 by 8 plus summation. So this is here minus 1 whole to the power r minus 1 multiplied by the even number, each of the gap, like 2, 4. Okay, this is 1.2, 3.4, dot 5, dot dot 2r minus 3. Okay, and this is here 1 by 2 to the power 2r. So here is 2 to the power factorial r, and 2 to the power 2r. So we multiply the factor 2, 4, 6 dot dot. The previous term of this expression here is 2r minus 4. Okay, so 13 by 8 plus summation, this is minus 1 whole to the power r. This is your factorial 2r minus 3, and this is 2 to the power 3r. If we take common 2 each and every factor, so if we take common here, then 2 common taken common, then within the bracket we get here r minus 2. So number of 2 here is 2 to the power r minus 2. Then the factor here is 1, 2, 3 dot dot to r minus 2. So this is factorial r minus 2. Okay. So this is equal to, again more, 13 by 8 plus summation. So summation minus 1 whole to the power r. Okay. Factorial 2r minus 3. Okay. This is 2 to the power 4r minus 2. And factorial, okay, factorial are missing. Okay, sorry, factorial r. So factorial r and factorial r minus 2. 2 to the power 4r minus 2. See, our form start here actually 2. As we take the 2 term for simplification, we got here, okay, this is adding these 2 term, 1 and 2 term are added with this expression 13 by 8. So next term are started from here, r equal to 2 to infinity. Check the expression. If we put here 2, then 2 to the power 4r minus 2, 8r minus 2, 2 to the power 8 minus 2, this is 6. So this is 6r means 2 to the power 6 is 64. Okay, if we put here 2, then we got here 2, and this is 0 means 1. If we put here, this is r minus 1. Okay, this is wrongly written here, r minus 1. If we put 2, then this is here 1. If we put 2, then we got here minus 1. So this is minus 1 by 128. 128. See, if we simplify, you got here 128. So first term start here 128. But needed to start here r equal to 0 to, for this n equal to 0 to infinity. So if we replace in place of r by n plus 2, then you got the perfect expression, and this is 8, and this is from r equal to okay, this is your n plus 2. Put r equal to n plus 2. Put r equal to n plus 2, then you got 0 to infinity. See, replacing minus 1 whole to the power. This is n plus 2 minus 1. This is 2 times of n plus 2 minus 3. This is a 2 to the power 4 times of n plus 2 minus 2. This is here n plus 2. This is here n plus 2 minus 2. Okay. So 13 by 8 plus summation n equal to 0 to infinity. N equal to 0 to infinity. That is minus 1 to the power n plus 1, and this is 2n plus 1 over, this is 2 to the power 4 times of n, 8 and this is 8 minus 2, 6 plus 6, and this is factorial n plus 2 and factorial n. So see, okay, and this is the right hand side. Okay, we start from left hand side, and this is equal to right hand side from 5. Okay, proved. Okay, thank you for watching my video, everybody.